Hassan, I believe.
All right.
There we go.
That was an oversight. I want to start by thanking the organizers for having us all here and putting this paper on the program in particular. I will be talking about selection in information acquisition and monitoring non-neutrality, which is joint work with Choongryul Yang at Federal Reserve Board. I am obliged to say that the views here are our own, and the Fed is in no way responsible for what I say here today. So I want to start motivating this project by hinting at the immense empirical literature that has now emerged from survey data on firms' expectations. We know by now that the average firm in the economy is very uninformed about economic outcomes. This is more recently, this is the series of papers published by, for example, Koiven and Gornichenko, who show that in New Zealand, Italy, the US, firms don't necessarily follow economic news, and they have very uninformed expectations about the economy on average. However, one aspect of the survey data that is not explored as much is the vast heterogeneity that exists in firms' information sets. In particular, even though that the average firm is very uninformed, there is a lot of variance in this on being informed about the economy. Some firms are very, very informed, and some firms are even more uninformed than the average firm. So this raises the natural question that if we think expectations matter for economic outcomes, in light of this heterogeneity, whose expectations matter for macroeconomic outcomes? Should we actually plug in the average expectations that we listed in these survey data, or is there some kind of non-trivial forces at work here that affect how we should think about the answer to this question? So what I will be talking about today is a particular aspect of this question, where I'm going to show that first, just motivating evidence that subjective uncertainty, or how much firms know about economic outcomes, is positively correlated with the time since their last price change. So not only there's heterogeneity and uncertainty on the part of firms, but this uncertainty correlates with firms' time since last price change. This already should bring up the idea of selection here, that, oh, firms that have made decisions more recently tend to be more informed than their peers. Then we're going to write a model with a state-dependent information acquisition to show you that actually in that model, the selection is rationalized. And in doing so, I'm also going to write an alternative model in which this is not rationalized, so that you see that this is not the only model that one can come up with, and there are actually different models of the world that have different predictions. And how this evidence actually allows us to select the right model to approach the data. And then from the lens of that model, I'm going to ask the question that, okay, whose expectations matter? And in this case, I'm going to look at monitoring non-neutrality, and we're going to show that in the model that is consistent with the evidence, it's only the expectations of the most informed firms that matter for monitoring non-neutrality. So never mind that we have this huge heterogeneity and the fact that the average firm is really uninformed, the model is telling us that we should be focusing on the expectations of the most informed firms. So the message is going to be that depending on whether this evidence persists as we go forward with these surveys, the way that we should conduct those surveys and the firms that we should look at in those surveys change based on the implications of such a model. So I want to start by showing you a motivating graph. The underlying data that I'm going to use here is a survey of firms' expectations from New Zealand that has been introduced by Koiven and Gornichenko, and in a relatively recent paper by now from 2018. what they do in that paper, they go to firms in New Zealand and they ask them about different economic outcomes. One of the questions that they ask is about the firm's own prices. So basically, they go to the firm and they ask, if you could change your price freely today, by how much would you change that price? And in eliciting that answer, not only they ask for what that price should be, but also they ask the firm to assign probabilities to different outcomes. So instead of eliciting a point forecast, they're eliciting a whole distribution from the firm. I can take that distribution and I can look at the variance of that distribution. I'm going to call that the subjective uncertainty of the firm about their own price change. Now, why is this an interesting object? Two reasons. First, the model will actually tell us that this is an object to look at for information frictions, but also it is indicative of information frictions by itself, because under rational expectations, there's no reason to believe that if a firm is able to change their price immediately at this moment, there's no reason to think that they don't know what that price should be. Whereas in the data, we see that they have a lot of uncertainty about this object, but also that uncertainty is very heterogeneous across different firms. It survives controlling for firm characteristics that are permanent over time. It survived looking at different industries. And it's a very robust prediction that a lot of firms are very certain about what their price should be, but there is also a non-negligible mass of firms that are very uncertain. In an economy where the standard deviation of inflation is 1%, we have firms that have 3% standard deviation uncertainty about what their price should be. So that's number one.
And
number two,
Hassan, can I come back to the question I'd asked you in the other talk earlier today?
Yeah, I hope I answered at least like partially. But then
you did, but it came to me that in this previous figure, if you go back, this is all firms pooled, and I completely understand the complexity of asking surveys. There is, of course, the question that I've always gotten to, like, what is the price you're talking about here? To what extent are these multi-product firms where the pricing technology will be different, potentially also depending on many factors, but that might also influence the uncertainty, because you receive different information and many more signals than just one. Do you have anything? Is there anything you can do in that survey, or is this something for future research?
Yeah, so one thing that we have done, one thing that we could do and is possible we haven't done. So what we have done is that, like, in the survey, when they ask these questions, when there is multi-product firms, the question specifies that talk about your main product. So this is like, at least it qualifies that what we are asking here is your main product line. Now, another thing that we could do and we haven't done, I think, like in controlling for this has already absorbed some of the variation coming from like the obvious controls, but we have not controlled for the number of products. However, there is data on a subset of firms that ask them how many products do you have. So we can actually condition on that and look at, like, depending on how many products do you have, if that the firm has, if this graph changes. It's going to cut the data to be very thin, because like this is not a lot of, this is only coming from one wave and there's not a lot of observations, but we can do that. The rest will have to do with future research, because finding data on what firms think their optimal price should be in terms of a distribution is a very new thing in surveys that is not very prevalent in other data sets.
No, I fully agree. If you could cut this in very simple ways, I think it'd be super informative. Especially, I've already seen your results, right? That there's a relation to the frequency, and we know multi-product firms have very different patterns of frequency of price adjustment. You might actually be able to learn something more about the different results that you that validate or don't validate what your predictions are.
Absolutely, no, that's a great point, and I actually took a note here for multi-product, because we can do a little bit more on that front. All right, so the next piece of evidence is that I want to show you how this uncertainty object that I calculated for every firm correlates with time since last price change. So I'm going to take that observation for each firm, and I'm going to first start by regressing it on a dummy that asks the firm if the firm has changed their price in the last year or not. Okay, and what we see here is that firms that have changed their prices during the last 12 months, they have lower subjective uncertainty about what their price should be than their peers. That's just like observation number one. Observation number two is that this correlation becomes even stronger when we start controlling for firm level controls, including size and the number of competitors, which people have noticed before that are important for uncertainty. But on top of that, we also control for the firm's average frequency of price change. So there might be heterogeneity across different firms in terms of how frequently they change their prices, and that might affect how frequently firms acquire information. In the survey, there's a question that asks about that. So we can control for that and then look at the residual correlation, which is this column 2. We can add manager controls, becomes even stronger. And finally, even though that this one was coming from a dummy, we can go further and we can actually control, like, rather than regressing it on a dummy, regress it on the time since last price change. And what we expect based on what we've seen so far is that there should be a positive correlation between time since last price change. Now it's in months, it could be 1, 2, 3, whatever. And firm subjective uncertainty, this is almost significant at the 2 standard deviation level, but just didn't barely make it. But again, motivating evidence, I just want you to see that the theory that I'm going to write is not totally unfounded, and there is something going on in the data in that direction. So the results that I showed you so far indicate 2 frictions. The nominal frictions, which is that even when we ask firms whether if they can change their prices, they rarely say, I would never change to any other price. I'm already at my optimal price, which indicates that even from the firm's perspective, they're away from their optimal price. I'm going to add that with a Calvo friction, the simplest way possible. And then in order to model the uncertainty around that object and the fact that that uncertainty correlates with firm characteristics, I'm going to add endogenous information acquisition a la Calvo. So just to dive into the model very quickly, just the setup is going to be that time is continuous. There's going to be a measure of ex-ante identical price setting firms indexed by I. And because I'm looking for analytical results, I'm just going to assume that firms' instantaneous profit is just a quadratic function. And firms lose profit if their price deviates from an optimal price, which in a new Keynesian model would be the deviation of the marginal cost from its steady state level. So if the firm manages to realize what that marginal cost is and set their price equal to that, their profit is maximized. If not, they're going to lose profits from that. There could be markups here. We've just normalized it because these are deviations rather than levels. And we're going to assume that this marginal cost process is just going to be a Brownian motion for simplicity. There's a Calvo friction in the background. The price change opportunities arrive at a Poisson rate. On information acquisition front, firms are going to acquire information about this marginal cost. They don't see it for free, but they can produce arbitrarily precise signals about it, subject to a cost. What does that mean is that they're going to see signals of this marginal cost process where they control the precision of the noise. If the noise is 0, I perfectly observe it. If the noise is infinity, I just didn't observe anything today. Then based on this, I can define the information set of the firm as the sequence of signals that they've seen up until a particular time, and define the attention problem of the firm in choosing these precisions subject to the cost, which is going to be increasing and convex in the Shannon's mutual information, which is the traditional way to model costs in rational attention literature. For those of you who are not familiar with Shannon, this is just a measure of how much the entropy of the firm's belief about their optimal price decreases after information acquisition, and basically the cost is increasing in that object. The problem of the firm,
just, about 5 minutes.
Perfect.
That's okay.
All right, sounds great. So in terms of the firm's problem, the firm is going to minimize their losses. There are 2 sources of losses. My price can be away from this optimal price. That's just like losses from mispricing. but also there are costs of information acquisition. By acquiring more information, I can reduce this distance and reduce my losses from mispricing, but instead I have to pay information costs. I have to pay analysts to actually figure out what my price is going to be, or I have to spend time on it, which is still costly. Subject to the fact that price change opportunities arrive at this Poisson rate theta, which is the Calvo friction, and the information set evolves according to this law of motion, where the firm is controlling the precision. Now, today I'm going to show you results for two particular cost functions. One is going to be linear, one is going to be extremely convex. And the idea here is that I want to show you that not every model is going to deliver the predictions that I'm going to show you, and actually the data will allow us to select one from these two, the menu of these two models. So just the convention of matching the model objects to the data, it is common in the pricing literature to think about price gaps or the deviation of the price from what its optimal level is. Here we can decompose that object even further. There's going to be the component of this object that the firm knows, which is their perceived price gap. But because of information frictions, there's also going to be a subjective variance around this object, which is basically the graph of what I was showing you in the beginning of the talk. It's that distribution that I just showed you. And it turns out that these are the sufficient state variables for the firm to carry over time in terms of their problem. In particular, information acquisition is just controlling this variance, and that's going to create the correlations that I see in the data. So just quickly, the results. With linear information costs, it's never optimal to acquire information in between price changes. So think about convexity as an incentive for smoothing. If cost of information is linear, there's no smoothing in information acquisition. I wait until the last moment I need information, which is the time I need to change my price, and I change my price at that moment. Upon the arrival of the opportunity for a price change, however, firms are going to always bunch information acquisition and acquire enough information to reduce their uncertainty to a baseline level, which is characterized by this equation. The specifics doesn't matter, but I want you to see that it matters for incentive. Incentives matter. If you have a higher curvature of the profit function, this uncertainty is lower. Cost matters, discounting matters, frequency of price changes matters, which is like all like the comparative statics would relate to things that, for example, me and Raphael were talking in the beginning of the talk based on different firm characteristics. So the linear model is a model where uncertainty grows linearly with time, and whenever the opportunity arrives, it resets to a lower bound. In contrast, the extremely convex model would be a model in which firms extremely smooth information acquisition, they acquire information at a constant rate. It doesn't matter if they're setting prices or if they're not setting prices, everyone has the same uncertainty, everyone has the same type of information set. Well, what are the implications for the graphs that I showed you? Well, in the convex model, it's really obvious. Everyone has the same uncertainty. There's a mass point. So if I control for firm characteristic, everyone should be at the same point in terms of their uncertainty if there is no other time varying heterogeneity. Whereas in the model with linear costs, the distribution of uncertainty is going to inherit the distribution between the price changes, and it's going to be a shifted exponential. And the idea is that I want you to see that this is very similar to the graph that I showed you in the beginning. So the model is much closer, this model is much closer to the data than the alternative of having convex costs. Finally, one last thing, and then I'm done. I want to basically just tell you about the implications of this model for macroeconomic outcomes. That's why we wrote this model to begin with. So in this model, I'm going to introduce a monetary shock. I'm going to look at the impulse response of output, and I'm going to calculate the integral beneath that impulse response. Call it the cumulative response of output. For those of you who are familiar with the Alvarez-Lippi kind of measures, this is exactly what they do. And the idea is that what is the area under that impulse response? That's kind of like the aggregate response of output to a monetary shock. Normalize the size of shock to 1. That object is going to be a sum of two components. One is going to depend on frequency. This is the familiar why Calvo creates monetary non-neutrality. This is the sufficient statistic in many of the models that are out there, including it's a special case of the Alvarez-Lippi sufficient statistic for these types of models. What's new here,
You'll have to be finishing up, okay?
All right, sounds great. One last comment is that what is new here and what's zero in those other models is this new term, which is the role of information frictions and how information frictions amplify monetary non-neutrality. And the idea here is that it's going to be related to uncertainty, the object that I showed you in the beginning, but it's going to be related to the uncertainty of the most informed firms rather than the average firm. Okay, so the model is telling us to look at the firms and the beliefs of the firms that are the most informed in the economy, which is very far away from looking at a representative firm in the economy. With that, I want to finish. We show that there's evidence for selection and information acquisition in the data. We show it's consistent with the state-dependent information acquisition model. And finally, we show that selection implies that only the most informed firms' expectations matter for output response to monetary shocks, as an example of a macroeconomic outcome, which has implications for how we should conduct surveys and how we should think about the objects that we elicit in surveys about expectations. Thank you. I'll stop talking.
All right, fantastic. This is a great paper. If there are questions in the audience, just please type it into the chat. I see we have nearly 40 people, so then I will just ask you to speak up. Please go ahead. Okay, well, I already asked there is one question from Christoph.
Yeah.
Christoph, please go ahead.
Thanks, Hassan, for this very interesting presentation. I wonder, maybe you can comment on one question that I have. In your theorem that you say that on point 1 that there's no information acquisition when no opportunity arises for price changes. That's, of course, a little bit by assumption of your Calvo structure, and that there's no learning of firms. They do not really track their competitors when what I think is more realistic to say, well, to move when a competitor has moved. So this Calvo assumption structuring of price change, price resetting might have some impact on your distribution of informed firms as an outcome. What do you think about this?
That's a great question. So if I may rephrase it a little bit, because I think it goes actually beyond just looking at competitors. So I think information, just to zoom out a little bit, information can matter to a firm for two different reasons. One is I might use information to infer when I should actually move and make decisions. It could be looking at competitors. It could be actually just looking at other things that matter for my pricing decision and decide whether it's a good time to actually change prices or not. And then when I decide to change prices, then I use information to also figure out how I should change or how much I should change my price. So you're right that by assuming Calvo, I completely ruled out that first margin that firms might use information to decide when is a good time to change their prices. So that's a very good question, very important point, and we've started working on it. I didn't show you anything because we don't have the results for that, but we do consider a menu cost model in which both margins are present, and firms can use information to decide when is a good time to change price based on when is a good time to pay the fixed cost and change their prices. And we could interpret freely the fixed cost as oh, am I close enough to my competitors or not? That's worth paying the fixed cost or not. And then also when they decide to change their prices, they have to figure out what that price is. In that model, you're right that it attenuates a little bit the selection margin, because even the firms that are not changing their prices are now more informed than they would have been if they didn't have this new margin of adjustment. But the heterogeneity still persists. So it becomes a quantitative question that if we calibrate a model to the data that has both margins, and we somehow inform the model to calibrate or to match those moments, is the selection going to be strong enough? And my prior is that given that the US data, for example, is very much closer to a Calvo model than a menu cost model, we know that in stable environments, firms don't really use information much to decide when to change because changes are pretty much random. The selection is going to be quantitatively important, but I'm just speculating there. I don't know the answer. I need to do it and then report back. But very good question. Thank you so much.
And there's also a question from an anonymous attendee in the Q&A, which I read to you. Could you provide us with an intuition of your last result? Why would only the expectations of the most informed firms matter?
Right. So I didn't go into it, but it's not very simple. I'm still trying to understand the intuition myself. But the best way that I've come up with yet is that there are two channels that matter for whose expectations matter for monetary non-neutrality. Channel number one is that when I have heterogeneity in information acquisition, well, we know that imperfect information amplifies monetary non-neutrality. So if I have a lot of uninformed firms, they're going to amplify monetary non-neutrality through this channel. But what turns out to be the case in the model is that, well, when those guys get to acquire information and reset their prices, they realize that they're very uncertain about the economy. So they have very high learning rates. So it's not, if I fix the learning rate across firms, then only the expectation of the average firm would matter. But because in the model, when firms get to change their prices based on their baseline uncertainty, more uninformed firms acquire more information and are more aggressive in resetting their prices. And when they reset, when they reset more aggressively, they undo this first channel and reduce their impact on monetary non-neutrality. And it turns out that these two forces exactly cancel each other out in the model that I have written. That's the part that I don't have a really good intuition of why that happens. It happens when you start from the stationary distribution and shock the economy. It's not always the case that for any other arbitrary initial distribution, they don't cancel each other perfectly out. But basically, that's the result. Yes, more uninformed firms have higher effect potentially on monetary non-neutrality, but endogenous information acquisition incentivizes them to undo this by responding more aggressively to price changes.
Okay, we have one last question that I think I'll take as a clarifying question. Does your model imply that firms that change price frequently will be the most informed? And if so, does this argue against some of the sticky price literature, Aoki and others, that suggest sticky price firms tend to have an embedded inflation expectations component in their price setting behavior? And please try to be brief, we have to move on.
Right. So the answer is not obvious. So the competitive statics of information acquisition with respect to frequency is not monotonic because yes, increasing frequency of price changes increases the benefit of information acquisition for me because I make decisions more frequently, so I should have more information, but also increases the frequency at which I acquire information, right? So I have to pay more if I want to acquire information at the same rate as the other guys do, I have to do it more frequently and pay a higher cost more frequently. Because I'm paying it more frequently. So depending on the frequency of how much this cost is going to be paid and the trade-offs between the cost of information and the cost of mispricing, there's a region where this is increasing and there's a region where this is decreasing. So I'm still working on that. This is like the best answer that I have at the moment, but very good question. And I will think about the second point more. At this point, I don't have a really good answer for what happens for the inflation expectation component.
Okay, thank you so much to the audience and to Hassan, and we will move on to Christoph. If you would mind sharing your screen, please.
Yes, I will share my screen now with you. So, can you see it?
Yes.
Okay. Thank you very much to the organizers for including this paper into the program. It's about anchoring of inflation expectations. And a specific question I raise in this paper is whether the inflation target formulation matters for anchoring. And these are my own views and do not represent the views of the Banque de France, where I'm working, or the Euro system.
Christoph, do you mind making this full screen? It's still like a small screen.
Is it better now?
Yeah, yes, great. Thank you.
I don't see how it shows up for you guys. So thanks for these kind of comments. Quantitative formulations of inflation objectives are nowadays very common due to the prominence of inflation targeting regimes, which highlight really this fact of steering monetary policy. However, still there's some heterogeneity how those inflation objectives are formulated. They differ not only across country, but also across time. So some central banks decide from time to time to change. And to give you two examples, there's, for example, for the New Zealand case that operated with a corridor of 1 to 3% for much of the past, and they decided in 2014 to emphasize the midpoint and make this explicit in their monetary policy strategy. And another example would be the case of Sweden, which operated with a point target plus an explicit tolerance band. Until 2009, they decided, well, let's abandon this explicit numerical definition of a tolerance band. We don't need it anymore. Just let's say we target 2% and that's it. However, they were not really quite happy about this either. So they were revising their decision in 2000 and reintroduced in 2017 a so-called variational band. So they changed the name. But basically, as you see on the right panel, it's again a point target of 2% plus this variational band of 2 to 3%. So I follow a little bit I follow mostly the literature and come up with a classification of 4 different target formulations. First, there's no precise numerical target. That was the US prior to their strategy review in 2012, where they introduced the 2% objective. There's also the famous case of the Euro area, which is has defined close but below 2% as a target, which is numerically not very precise. As a second classification, there are target ranges. For example, Australia targets 2 to 3% as a thick point, and Switzerland has also a corridor of 0 to 2, and Israel. Then there are, actually that's the most common formulation, hybrid targets, either a point target plus tolerance band, as you've seen in the case of Sweden, or a range plus a focal point, as I showed you the case of New Zealand. And Canada and Czech Republic are other popular examples. And finally, there are pure point targets like the UK or the United States or Sweden, at least for this intermediate period. So the big question that I ask in this paper is, does the inflation target formulation matter empirically for expectations anchoring? So, why should at all this matter for anchoring? The theory has different views on the topic, including different and actually conflicting predictions. So in the earlier literature promoted by Jeremy Stein, still motivated by time and consistency problems, he argued that any precise announcement of a central bank inflation target is problematic. Markets will take it as cheap talk and actually explicitly deviate with their expectations because they don't believe in it. So the prediction would be that a precise numerical target would disanchor expectations, and more vague non-numerical definitions of price stability are better. Then there's a sequence of papers arguing that ranges are actually much more credible, because if you look ex post at inflation realizations, it's very uncommon that inflation is at 2% all the time. Of course, it fluctuates around it. We know why. There are shocks. There's a monetary policy lag to bring it back to target, but the general public might not understand those complications. So having an explicit range makes it much more credible and improves anchoring of expectations. And thirdly, there's a series of papers arguing that an explicit range increases flexibility for the policymaker. They can pursue secondary objectives more strongly, which might let inflation revert slower to target. That's why a point target is actually better, because it signals that they are more committed to this. So these testable predictions are the focus of this paper. I take an empirical approach in a panel model with 29 different countries, 12 advanced economies and 17 emerging market economies. The sample period stretches 15 years of quarterly data, unbalanced in the countries, and I use private sector point forecasts over multiple horizons, from medium term of 2-year up to very long term 6-year inflation forecasts. And I propose a novel anchoring measure, which is in levels. Hassan has a nice paper with Kumar and Koebion and Gorodnichenko, where he gives different criteria for anchoring, because it's not well defined. And we look at the anchoring in terms of levels with respect to the midpoint of the inflation target. And we actually derive a cross-sectional distribution across point forecasters from consensus data, such that we can also analyze the symmetry of these beliefs of different agents, and also the tails of this distribution of beliefs, where we interpret actually each point forecast as the best prediction of a panelist. So the main findings are that numerical target definitions with a midpoint have better anchoring properties compared to quantitative definitions of price stability. So that's against this prediction of the cheap talk model. Point targets overall improve expectations, anchoring of expectations, and an unconditional effect, where we actually look at all times. And when we actually condition on the inflation track record, we find that there's less disanchoring when there is in the presence of a point target than when there is a target range, which is in line with some of those theories promoting this flexibility view. And however, broadly speaking, I do not find any that tolerance bands or explicit variational bands have adverse side effects, but they are less effective in limiting the shifts and tails of the belief distribution during periods of sustained deviations from target. So these are the main implications. I will skip the discussion of the literature for the sake of time, and now we'll talk about the data. So, and this anchoring measure that I put forward in this paper. As I said before, I use consensus data, where this it's a consensus is a company that collects point forecasts from the private sector and banks, research institutes, sometimes public institutions, and I actually fit a parametric density function, and I use a quite flexible one, the skew extended t distribution from defined as in Jones and Fetty, and it's very flexible with 4 parameters. So it features fat tails and skew non-negative, non-zero skewness, so it's asymmetric. And I estimated using simulated method of moments approach, because I have limited information on medium to longer term inflation expectations. I do not have the entire micro data, so all the responses of the panelists. Instead, consensus only publishes the mean forecast, the standard deviation, and the highest and the lowest observation in the sample. So there are 4 data points, or 2 data points plus 2 moments. And I estimate those skew extended t distributions using those 4 pieces of information. And in the paper, there's lots of material on the technical details. However, for the sake of time, I leave that to the end of the talk if there are questions on this. So for each country and quarter, I get a distribution which looks roughly like this on the right-hand, or precisely like this on the right-hand side. You see the 2-year horizon on the top and the 6-year horizon on the bottom for this believed distribution of beliefs. And you find the mean on the bottom here and the lowest and the highest data points, and then the very smooth, because it's a continuous parametric density function here. And then define an anchoring measure as the probability of those beliefs falling in a very narrow interval of plus 10 basis points or minus 10 basis points around the inflation objective. Everything below that is my disanchoring measure due to low inflation. That is the light blue shaded area. And everything to the right of this interval is a disanchoring measure due to high inflation. So you can already see that it changes with the forecast horizon. It's also theory consistent. Actually, in the paper, I revisit a model proposed by Kilian and Manganelli, published in the JMCB in 2008, where they look at an optimal policy rule when central bankers have potentially asymmetric preferences, and the optimal policy rule is intuitively a weighting of upside and downside risks to the inflation outlook. To some extent, you can think that directly those measures of disanchoring enter the policy rule of a central banker that has asymmetric preferences and is risk averse. But for the sake of time, I do not revisit this model here. Instead, I would like to give you some intuition on the data. Of course, I run a simple regression first, where here's a generic dependent variable of country I, quarter T, and horizon H. And I look, what is the effect of the forecast horizon? I define a dummy for each forecast horizon, up to a forecast horizon of 6 years. And if there's a difference in emerging market countries, and I control for the volatility of realized inflation in a rolling window of the past 2 years. I have year fixed effects, and the reference group in the constant is the advanced economy with forecast horizon of 2 years. And what I would like to highlight is that here in column 4, it's the main anchoring measure. And you see that the more you go into longer forecast horizons, the better is the anchoring property. That's quite intuitive. Temporary shocks drive inflation rate away from target, and forecasters expect some reversion to the target in best of all policymakers' worlds, of course. That's what we wish for. And that's what the data tells us. I include some non-generated data as well, like the distance of the mean, and here the same property arises. And intuitively, emerging market countries have slightly less well-anchored inflation expectations. So now let me go directly to the tests of the predictions of comparing this alternative inflation targeting formulations. I first estimate this specification where I have a dummy for any sort of a range, either tolerance band or pure range target and some numerical reference point in the middle. And the control group and the constant would be any regime that has not a numerically defined objective, like the euro area and the US before giving itself the 2% objective. And what I find—
just a quick message, just 5 minutes. Thank you.
Thanks, Rob. I can't do that. So what I find here is that actually only the numerical point reference to a midpoint improves in expectations anchoring across all forecast horizons. And the numerical range actually either has no effect or even a negative effect. So in the end, the euro area and the US were not faring that bad compared to some countries that have explicit range when it comes to anchoring. And that's one result. The second result that's actually more to the point of this paper is where I explicitly compare only numerical targets. So we leave now aside all classifications that have a vague definition of price stability. So the euro area drops from the sample. I'm left with 28 countries. And now I have defined a hybrid regime, like a tolerance band plus a point target. I have a pure point target, and the reference group are target ranges. And what I find is that both hybrid ranges and point targets increase anchoring properties across all forecast horizons, and with respect to pure target ranges. And I also apply a F-test to see whether there are significant differences. Most of the time, the effects are not significantly different from each other. This implies that they're more or less equally well compared or improving equally well compared to range target. So far so good for the unconditional effects of these different regimes. And now I look and an extension also add conditional effects based on the track record of inflation. I look at actually the deviation of inflation, realized inflation from the target, and for the last 60 months, and collected in this variable CL, which represents multiple things, either the persistence of certain shocks or a credibility loss that makes that inflation expectations get disanchored because of the poor performance of the central bank's inflation track record. And I actually split it in cumulative undershootings and cumulative overshootings to see whether these effects are symmetric or not. And what I find actually in an interaction between this track record and my classifications of the regimes is the following, is that point targets are most effective in limiting the shifts in the tails of the distribution. So what I like to show you now is that conditional on having an overshooting scenario, the hybrid model lowers somehow the disanchoring measure due to high inflation, and also the point target lowers the disanchoring measure due to high inflation. So what is happening here? You have realized inflation that is for a certain period of time above your target. And of course, professional forecasters might internalize that into their forecast. They might drive up the distribution of beliefs. And what I show here with those estimation results is that once you have a hybrid version or a point target, you actually limit this shift in the belief distribution along the line, conditional on your track record. And actually the same happens when we look at undershooting. which is a kind of interesting scenario for advanced economies today due to the effective lower bound and persistent low inflation. And also here we find that what you want as a central bank is then that this anchoring due to low inflation is lower. And I find, in fact, that this is the case. However, the magnitude is much higher for a point target than for hybrid regimes.
So Christoph, you have about a minute left, please.
Thanks. So let me conclude. So the debate about the pros and cons of inflation target formulations is largely unsettled. And this is reflected in numerous central bank strategy reviews from Sweden to the US and Canada, New Zealand, and also the European Central Bank. And the challenges of disanchoring remain present due to persistently low or high inflation. And the anchoring measure I propose here in this paper is consistent with a risk management approach to central banking, something that practitioners have put forward actually in speeches since many years now. And I found that the main finding is that point targets have favorable anchoring characteristics. However, I'm aware that there are some limitations, namely that professional forecasters are quite attentive to central bank announcements. We know that professional forecasters' views are mediatized and affect other agents, was shown in a paper published in the QJE in 2003, but still it's not sure if those results, those conditional and unconditional effects of different target formulations would hold for expectations of households and firms, because recent research shows that they're much less attentive to central bank communication. Thank you very much.
Great. Thank you so much, Christoph. This is a lot to digest. A very topical research also. So if there are any questions, actually, I believe there is one from my colleague, Randy, who has two questions. I read them to you. I've used plus minus 2 percentage points in my work, and some object to this is arbitrary. Is there any specific reason to use plus minus 1 percentage point or 10? I think you had 10 basis points, right?
Yes.
So sorry if I'm reading this wrong here. So how do you define this? And so the first question.
Yeah.
Is there any specific reason? And second, how do you define this anchoring target for countries with a band? In some sense, there's no target, only a range. So perhaps for those countries, you need to use something like plus, like some different amount.
I think they belong together. These thanks, Randy, for your questions. So I take the 10 plus minus 10 basis points a bit for pragmatic reasons. So what I find is that I would like to recall to you that we're talking about distributions across point forecasts. There's a nice paper by a colleague of mine, Sarah Mouabi, published in the MCB, where they have the subjective distribution, the subjective uncertainty, and they can come up with a distribution of inflation forecasts for the SPF in the US and the euro area. And this is much more spread out. Here for the euro area, you see that the point forecasts lie between 0 and 2.2. So some people think that 2 years ahead, you have zero inflation, and so it's already quite dispersed. However, it's their best prediction. Now, having said that, it means that for longer horizons, they narrow down quite significantly, as you see below. And if I take much more than plus minus 10 basis points, these anchoring measures become a bit pathological, because they are either 0 or 1 all the time. And so unfortunately, I cannot map the de jure ranges into my measure, because I'm dealing only with distributions of point forecasts.
Okay, so I will read the next question from Bob Titlow. Many central banks in history adopted targeting just inflation as a target, omitting an output or an employment mandate. This was done to enhance the credibility of the inflation target, in my assessment. Did you test for any effects of central banks having a second target variable?
No, I didn't. Very interesting point, but I didn't. Oh.
Okay, we have another question from an anonymous attendee. Have you checked endogeneity? I think about the possibility that central banks that face more uncertainty prefer to add the band/range to the communication of their target.
That's a valid point. So I'd like to show you one of those baseline regression specifications. I cannot account. I cannot do much to. So the underlying hypothesis from the person who asked this question is that there might be an omitted variable that selects. Because central banks can define their target formulation, so they might, if they have weak anchoring, they might go right away with a band or a corridor. However, when they know they have very good anchoring properties, they might just go for a point target. I have country fixed effects. I have year fixed effects to control for some unobserved country characteristics. If this is correlated due to a missing variable, I cannot fully control for it. So techniques would be propensity score matching to deal with this, but the variation of countries having a range and like clustering them using propensity score, it does not allow, unfortunately, to apply those techniques to deal slightly better with this indigeneity problem. So in the end, it's not fully tackled here.
Okay, great. So if there are no more questions, thank you, Christoph, for the excellent presentation and the questions from the audience. And
Thank
we
you.
will continue.
Can everyone see this?
Yes.
And
please
hear
make
me
it
loud
full
and clear?
screen. That'd be great. Yeah, there we go. Perfect.
Great. Okay. So thanks a lot. Thanks to the Cleveland Fed for organizing a very interesting session, and of course for including our paper titled Inflation Expectations and the Slope of the Phillips Curve, and it's joint work with Kevin Lansing. So the usual Fed disclaimer applies. So as you all know, the Phillips curve has been a key relationship in monetary macro models and one of the main theoretical frameworks for monetary policy for decades. However, in the aftermath of the Great Recession, many economists have concluded that the Phillips curve relationship has become weaker over time, perhaps most prominently voiced by Fed Chair Jay Powell in the summer of 2019, where he said in a statement to Congress that the relationship between slack in the economy and inflation was strong 50 years ago, and that has gone away. So this figure provides some reduced form evidence that the Phillips curve relationship has weakened. So this figure plots the CBO output gap against the change in core inflation across two samples of US data. So first from 1960 to 1998, and then subsequently for the past roughly 20 years. And so according to this type of reduced form relationship frequently observed in the literature, it appears that the Phillips curve has become flatter over time. So the question is, has the Phillips curve actually become flatter? And that depends on what we mean when we say the Phillips curve. And the reason why we stress this is because economists actually often don't talk about the same thing. So if we assume that the true structural Phillips curve is represented by a new Keynesian Phillips curve, where inflation depends on expected inflation, the output gap, and some cost push shock, and kappa is then the true structural slope coefficient. So the question, of course, is how to model expected inflation. And the second and third equation here shows two types of reduced form representations of that Phillips curve. So the first is sort of a standard backward-looking Phillips curve, which is plotted down here. That's the same that I just showed you in the previous slide. So that basically assumes that you can proxy expected inflation with the lagged inflation rate. So note, if I subtract the lagged inflation rate on both sides of this equation, I'm going to obtain the change in inflation on the left-hand side. And that's what we plotted here. So the backward-looking Phillips curve has indeed become flatter. However, if we instead proxied expected inflation with a constant, as in expectations are perfectly anchored, we would actually obtain the exact opposite result. So this graph right here shows the output gap against the level of inflation over the same two time periods. And we see that from 1960 to 1998, the relationship is negative and highly insignificant. But then for the past roughly 20 years, we see that a highly significant and positive relationship has emerged in the data. And we refer to that as the resurrection of the original Phillips curve. So the empirical result, the empirical finding that the Phillips curve should have become flatter relies crucially on an assumption that expectations are essentially completely unanchored. Another way of saying pretty much the exact same thing is that the correlation between changes in inflation and the output gap has declined over time from around 0.14 in the first table to roughly 0. But the correlation between the level of inflation and the output gap has increased substantially over time, from slightly negative to around 0.4 for the past 20 years. Note that this relationship is stronger than this relationship ever was. Now, it's plausible to believe that these changing slope patterns are somehow related to the fact that inflation persistence has declined dramatically in the data, and that inflation volatility has also declined dramatically in the data. Also note in the rightmost panel here, we've computed all of the same moments, but for the period prior to the Great Recession, so from 1999 to 2007, and all these numbers are virtually identical to these numbers. So these shifting slope patterns appear to have occurred long before the onset of the Great Recession, almost a decade before that. Okay, how can we explain these changing slope patterns? So there are essentially three theories of the flatter Phillips curve. One is that the structural slope should have declined, so kappa should have declined. Another explanation, prominently voiced by Jim Bullard and a paper by McLean Sanreo, is that monetary policy blurs the statistical correlation between inflation and the output gap, working through the cost push shock. So we have an endogeneity problem here, and working through monetary policy, the cost push shock will induce a negative co-movement between inflation and the output gap. But note that both of these explanations would all else equal imply that the statistical correlation between inflation and the output gap would decline over time. And the exact opposite has happened in the data. This leads us to focus on an alternative theory, namely that inflation expectations have become more firmly anchored. And the key research questions, of course, being one, has the structural slope coefficient declined? And two, can anchoring simultaneously account for a flatter backward-looking Phillips curve and a resurrection of the original Phillips curve relationship? So what we do in this paper is twofold. So we have an empirical contribution first, and then a theoretical contribution. So the empirical contribution is to estimate a Phillips curve on US data that explicitly allows for changes in the degree of anchoring. And we find that when we explicitly allow for changes in the degree of anchoring, well, first we find that expectations have become much better anchored over the Great Moderation period, and that when you take that into account, the structural slope coefficient kappa has been almost completely stable for the past 60 years. The model resolves both of these inflation puzzles in the data. I'm not going to have time to talk about that today, but and then the theoretical contribution is to show in a simple new Keynesian model with an endogenous anchoring mechanism that if the Fed increases its Taylor rule coefficient on inflation, then that will serve to endogenously anchor agent subjective inflation expectations. And that in turn implies that the backward-looking Phillips curve will become flatter, but the original Phillips curve will be resurrected. So a monetary policy regime change will actually lead to a stronger statistical relationship between inflation and the output gap as observed in the data. It also allows us to account for the two other stylized effects, namely that inflation persistence has declined dramatically and inflation volatility has declined dramatically. Okay, so how do we formalize anchoring? Motivated by survey data, we postulate that expectations can be put on this functional form. So expectations follow a Kalman filter type forecast rule, where this gain parameter measures the sensitivity of expected inflation to incoming data, specifically to recent forecast errors. So this gain parameter can be viewed as an inverse measure of the degree of anchoring, meaning that if this parameter declines, then expectations become less sensitive to recent forecast errors. And that follows the definition provided by former Governor Ben Bernanke in 2007, that anchor refers to a situation where expectations are relatively insensitive to incoming data. Now, this is also the optimal forecast rule if an agent employs an unobserved components time series model to forecast inflation along the lines of Stott and Watson. And we're going to refer to that as a signal extraction type forecast rule. If we substitute this forecast rule into the Phillips curve, then we obtain this expression after solving for inflation on the left-hand side. And we see that inflation depends on three terms. So first, the lagged forecast, which is just given by the lagged forecast rule, a term involving the output gap, and a term involving the cost push shock. And we see that anchoring as measured by a decline in this parameter will affect all three terms. So first, it will reduce inflation persistence working through this lagged expectations term, which is a feature of the data. It will also reduce, for a given structural slope, reduce the sensitivity of inflation to the output gap. And finally, it will reduce the sensitivity of inflation to cost push shocks. So note that the output gap here is endogenous, so we're going to need to use instruments to estimate this relationship. And we're going to just use the generalized IV using lag variables as instruments following Galli and Girdler with a small set of standard instruments, and our inflation measure is core CPI inflation, and a gap measure. The gap measure is the output gap. And then we're going to estimate kappa and lambda across three subsamples of US data. And here are the results for that baseline model. So we've estimated the model on these three subsamples. So first the 60s and 70s, then the great moderation in the 80s and 90s and early 2000s, and then finally the Great Recession period from 2007 onwards. And we see that over these three time periods, that expectations have become increasingly more anchored, going from a value around 0.3 to around 0.12, and then for the period from 2007 onwards, we can statistically reject that expectations have been perfectly anchored. So a gain parameter around 0. When we take this anchoring process into account, we see that the structural slope coefficient is almost completely stable over time and continues to be highly significant. And we conduct numerous robustness checks in the paper. I'm just going to show you this one, where we, instead of explicitly modeling expected inflation, we just use survey measures of expected inflation to estimate the Phillips curve. Both short-run professional forecasts and long-run forecasts of both consumers and professionals. And two things that are worth noting. First, when we use long-run expectations, we obtain virtually identical slope coefficients as we did in our model. So around 0.4 and 0.6, pretty much the same, especially when we use the SPF. And also note that all of these coefficients increase over time. There's literally no evidence that the structural slope should have declined over time. If anything, it has increased. Great. I'm going to skip this in the interest of time and look at how a shift towards more hawkish monetary policy will affect the degree of anchoring. And and the reduced form slopes of the backward-looking Phillips curve and the original Phillips curve. So as I mentioned earlier, a counterfactual implication of rational expectations models is that a more hawkish monetary policy that will reduce the statistical correlation between inflation and the output gap. And so in this section, we show that having an endogenous anchoring mechanism in the model will overturn that counterfactual prediction. So consider a standard new Keynesian model consisting of Phillips curve, an IS curve, and a Taylor type policy rule where the Fed responds to forecasts of inflation, forecasts of the output gap. And here we have subjective forecast rules, and the inflation forecast rule is the same that I just showed you, where this lambda pi measures the degree of anchoring or expected inflation. Okay, so how would anchoring affect the relationship between inflation and the output gap in this model? So if we consider a simplified version of the model where output gap expectations are constant and we just normalize this lag expectations term to 0, then the covariance between inflation and the output gap will be given by this term. So what we see here is that this relationship is determined by 3 factors. One that involves lagged inflation rates working through expectations, one that involves demand shocks, and one that involves cost push shocks. And note the signs. So obviously, demand shocks will induce negative co-movement between inflation and the output gap. That's pretty intuitive. But both cost push shocks and lagged inflation rates will induce negative co-movement, blurring the statistical correlation. And they both work through monetary policy. Here we have the Taylor inflation coefficient right here. But note that the gain parameter enters right here and right here. So perfect anchoring, meaning lambda pi goes to 0, implies that both of these negative co-movement forces will be eliminated. Both terms will go to 0, going from negative to 0. And then straightforward to show that that if we simply regress inflation on the output gap as we would in a original Phillips curve type estimation, then we're actually going to recover the true structural slope coefficient.
So Peter, you have about 5 minutes.
Yes, thank you very much. Great. Okay. Can it also explain these shifting relative slope coefficients? So can it simultaneously explain why we see a flatter backward-looking Phillips curve while seeing a resurrection of the original Phillips curve? Note that the difference between the two slopes will be governed by this term right here, the co-movement between lagged inflation rates and the output gap. And that is the coefficient that is essential if you want to explain or understand these shifting slope patterns. So in a poorly anchored world, this coefficient will be negative. So lagged inflation rates will induce negative co-movement between inflation and the output gap, working through expectations. So in this case, the backward-looking slope will exceed the original slope. But improved anchoring will weaken that negative co-movement force, and that will serve to flatten the backward-looking Phillips curve relative to the original Phillips curve. And if you look at US data, this coefficient has indeed gone from negative to positive over time. Okay, so as I mentioned, all else equal, if we increase this policy rule coefficient, we're gonna all else equal find that the correlation between inflation and the output gap would decline over time. So we introduced this endogenous anchoring mechanism. So we need some kind of theory about how this Kalman gain is pinned down within the model. So we're gonna compute a fixed point learning equilibrium. We're gonna assume that agents use unobserved components models to forecast inflation in the output gap. And in that case, these signal extraction forecast rules that I showed you earlier would be perceived optimal by the agent. And we showed that the equilibrium gain parameter will be endogenously and uniquely pinned down by this statistic, the autocorrelation of inflation changes. And so intuitively, the endogenous anchoring mechanism will then be that if I increase my policy rule coefficient, I'm gonna reduce this coefficient right here. That's a measure of mean reversion. And that's going to anchor expected inflation, and that will, all else equal, serve to increase the correlation between inflation and the output gap through these two channels that I showed you in the previous slide. So the key question, of course, is how will a monetary policy regime change affect these reduced form slope coefficients when we have endogenous anchoring? So we're going to compute these moments for different values of the policy rule coefficient, and we're going to compare our model with a rational expectations version of the model with persistent shocks, for a standard calibration of the model where we use our estimated slope coefficient. And here we have the results. So the black lines are from the rational model, and the red lines are from our signal extraction model. And on the first axis here, we have different values of the inflation response coefficient. So the first thing we note is that when we increase the inflation response coefficient, we're going to endogenously anchor expected inflation. We're going to get an endogenous decline in the gain parameter. That's going to dramatically reduce inflation persistence in our model, as we see in the data, dramatically reduce inflation volatility, as we see in the data. It's going to flatten the backward-looking Phillips curve, and that's also the case in the rational model. But unlike the rational model, a more hawkish monetary policy will, with endogenous anchoring, actually increase the correlation between inflation and the output gap, going from slightly negative to quite positive, as we see in the data, leading to a resurrection of the original Phillips curve. So yes, it can overturn this counterfactual prediction of the rational model. So to conclude, we find that US inflation expectations have become much better anchored over the Great Moderation period. When you account for that, the structural slope coefficient is both significant and stable over time. The model resolves the inflation puzzles. I did not show you that, but it does. And finally, in a simple new Keynesian model, we show that a stronger Taylor rule response will endogenously anchor expectations, flatten the backward-looking Phillips curve, resurrect the original Phillips curve, reduce inflation volatility, and reduce inflation persistence. And that's all. Thank you.
Thank you so much, Peter. I think we have a few minutes if there are any questions from the audience, so please type them in the Q&A.
So
yeah, Rob,
Raphael,
please.
Yeah, so Peter, I really like this is really interesting. I was just curious at the very beginning. I know that Emmanuel Monk and Stefano Giuseppe have done something where they've talked about people trying to infer, like, if there's a time varying inflation target and sort of different learning rules that go along with it. That's how they've kind of explained some of the movements or the behavior of post-war US inflation in the 60s and 70s and things like that. I'm not sure how closely this draws upon it. It seems like they're both telling stories about sort of the Phillips curve and learning and things like that. So I was just wondering if there was a way that you could relate these findings to kind of that alternative story they told about sort of an unobserved inflation target and people sort of getting shocks and sort of moving away from it, having to learn about it and sort of move back.
Right. So I'm not like familiar with like the details of their methodology, but I read the papers a while ago, and they are sort of pretty closely correlated in terms of how you define anchoring, that it's a reduced sensitivity to forecast errors. So yeah, that we also refer to their paper in our paper that's another sort of finding that expectations have become more anchored over the Great Moderation period. I think they estimated directly on long-run expectations and short-run expectations and find similar patterns that we find that expectations start becoming anchored in the early 80s. But so they are definitely related, and I think there are similar findings. I'm not exactly familiar with whether they look at the implications for the Phillips curve relationship. But related approaches, definitely, yeah.
Okay, thanks.
All right. I unless there are any other questions, I believe we can all take a brief break. So I thank everybody for their excellent presentations and the audience for the questions. Thank you very much, and hopefully see you sometime in person again.
Thank you.
And
Right.
thanks again.
Thank you,
Bye.
Raphael and Rob.
Bye.
Hey, Hassan. Hey, Peter, that was a very nice presentation. I just wanted to say that was a really
Thanks,
nice
Robert.
presentation.
Thank you so
Yeah.
much. Appreciate
And
it.
I don't think we've had a chance to meet, but I just wanted to say that I saw the paper and I really enjoyed it a great deal. And
Thanks.
the other reason I just like it a lot is that I actually do a lot of work with expectations formation. I think a lot about measuring certain things, and especially I've occasionally sort of thought a little bit about anchoring and sort of how to measure that and how to think about that and communication and sort of being able to quantify those particular, those effects. So I just wanted to say,
Right. Thank you so much. Yeah, there are different approaches in terms of defining this anchoring concept. So like the level approach, like people explicitly expect inflation to be equal to 2%, and then sort of their approach in terms of like measuring the sensitivity, the updating sensitivity. So, but these are of course like closely related. But thank you so much. Really appreciate it.
So can I ask you a very, very quick question? I don't want to take up much of your time. I'm just trying to understand. So so I get the idea that with well-anchored inflation expectations, I'm just trying to think now about the level of the gap and the level of inflation. Is this just a pure demand sort of store? I'm just trying to kind of get the intuition on the higher sort of correlation between the levels. I'm just trying to think about, I mean, sort of with well-anchored inflation expectations, you're going to end up with sort of less, right? You're going to end up with less inflation. I'm just trying to think about if there's a simple intuition for the improved correlation between the levels, or am I thinking about it just in terms of demand shocks, or is that not the right way to think about it?
So the intuition is that the lagged inflation rates will induce negative co-movement between inflation and the output gap. So that's going to blur the correlation between the contemporary inflation rate and the contemporary output gap, right?
Okay.
Because like intuitively, if past inflation has been very high, people tend to have high expectations, right. and all else equal, that's going to feed into actual inflation through the Phillips curve. So that's going to increase actual realized inflation, and then the Fed responds by increasing its interest rate and lowering the output gap. So that means that you get negative co-movement between inflation and the output gap working through lagged inflation rates.
Okay.
But when expectations become anchored, that channel disappears because you no longer have any link between lagged inflation rates and actual inflation, which is also what we see in the data. We see a dramatic decline in persistence. So that negative effect that constantly blurs the correlation disappears. And all you have left is just a relationship between the inflation rate and the output gap. And the only thing that can basically blur that relationship is the cost push shock, which in our model also, the effect of the cost push shock would also disappear in the limit. But yeah, so yeah, that's if that explains. Does that answer?
No, that's fine. It's just been a long day and my brain just isn't working.
Yeah, of course.
Anyways, I really enjoyed it. It was really nice meeting you, and hope we get a chance to see you sometime soon. Then, okay.
Yeah,
and
I hope so too. Thank you so much. Thanks for including us. Thank you. All right.
Very good.
Bye.
You all.